Let's first solve this question. The most important thing that I've been telling you each and every day about physics is when you read the question, come up with data. Data is going to help you to know which formula you are supposed to use. A belt runs on a wheel of radius 44 centimeters during the time the wheel takes to coast uniformly to rest from an initial speed of 1.6 revolution per second or rev per second. 29 meters of the belt length passes over the wheel. Find the deceleration of the wheel and the number of revolution it turns. Whenever you hear the question asking you to find the number of revolution, they're asking you to find the theta. First, write your data that you have. From the information that I've been given, I can clearly see that I have got the radius, which is r, which is 44 centimeters. But I have to convert this into what? Into meters. So 44 divided by 100 ni 100 or 1000? 100, eh?
Yes, 100.
That becomes 0.44. What else do we have? It started from rest. What comes in your mind?
The initial velocity is 0.
So what velocity are we talking about there? You
So
can.
isn't it that the kind of it is done which is 0? It says from an initial speed of
Oh, sorry. It. Ah.
oh yes, yes.
So during the time the wheel takes to a coast uniformly to rest from an initial speed, yes. So the final is 0. We have an initial. So now what velocity? Are we talking about angular velocity or linear velocity?
Because of the units. Angular velocity.
Okay, we're talking about angular velocity because of the units. Okay. So the initial is 1.6 revolution per second. Then the final is 0. We don't know the alpha. Okay, and we don't know the theta. The question is, find the deceleration of the wheel. For the fact that we are not dealing with time, let's choose the formula which doesn't have time. In this case, the third formula becomes the best for us, not so? Hmm?
Yes.
So then we'll say the final squared is equal to the initial plus 2 alpha times theta. Our goal is to find, in fact, so here now, I can't continue with this formula. Why? Okay, so we also have, this is the distance, which is in meters. So that is now my displacement. My linear displacement is 29.5 meters. Did you see those two formulas I gave you? If you really got those two formulas, tutatu tuja. If at all I've got D and R, I can find theta, not so?
Yes.
Or maybe you have forgotten utu. Akakapa first. D is equal to theta times R. So for the fact that I have D here, I have R, I can find theta. Immediately when I find the theta, meaning I've already answered the second part of the question, which is saying find the number of revolutions. Now when using this formula, guys, when using this formula, D is equal to theta times R, the answer that you find, it is always in rad. When you're using this formula, the answer you are going to find, you're going to, is always in rad. But there's also another conversion that I want you to know. In one revolution, we have got 2 pi rad. Timveranaka? So if I want to convert revolution to rad, I can use this conversion, or rad to revolution, I can use this conversion. Now, my goal is to find theta. I'll divide both sides by r.
On the conversion, what about the part that has, I think, 360 something?
That one, forget about it. It's the same thing because in one revolution is 360 degrees.
Oh, okay.
So in one revolution, we have 360 degrees, which is the same as 2 pi. But we are going to be using this. Mune kutika.
Yes.
Theta is equal to d over r. So d is 29.5, r is 0.4. When you are learning physics, you are not supposed to be in class without a calculator. Then you are not serious. So right now, I can see people who are not serious. How many people are not serious? 67.0, which is the same as just 67 rad. You can clearly see that even them here, they found what? 67. But now this answer, if I want to convert this 67 rad into a revolution, what can I do using these conversions?
Divide it 2 by
I divide 67. I divide it by what?
2 pi.
So that rad and rad should cancel.
Yes.
So what is 67? That answer divided by 2 pi. What are you getting?
10.7.
10.7 revolution, or 10.67 revolution, which is what they found here. Now, the next thing after finding the theta, that is 10.7, now we can go ahead and find our alpha. So what we'll do, this is 0. The initial is 1. So I'm going now here, for the fact that the velocity is in revolution, I'm going to use theta in what? Revolution. Okay? And even them, the answer that they have presented here, it is in revolution. Now the question is, what if you convert, you put it in rad? Nothing is wrong. Now it will require you to convert this one now to, it has to go to rad per second if you want to use 67 rad as theta. So 1.6 squared plus 2 alpha, I don't know. This is 10.7. So this is 0. This I don't know. Then plus this is 2 times that guy is what? 21.4. Shift this guy to the other side, that becomes 1.6. I square it, that becomes 2.56. I've shifted it so it's now negative 21.4 alpha. Divide it by 21.4, 21.4. Therefore alpha becomes negative 0.1196. If I round it off, negative 0.12. That is now in revolution per second squared. Can we fail to answer such questions?
In the exam. Okay, no, but we won't fail.
Hmm?
We won't fail. We won't fail.
You will not fail. muri sure tisimungagwe?
awe sikuzadzwa.
Okay. Okay, cool. So the concept that I was teaching you now, let me first talk about another thing. We mentioned to say for a car to move around the circle, meaning that there should be a force that is directed toward the center. We mentioned about that. Now, here is the roundabout. If the car is moving back a roundabout, one thing I want you to understand is that if this is the car, it is moving in that direction. It has got angular velocity. For it to move around the circle is because of the friction force that is directed toward the center. Without the friction force, the car can't move around the circle. That's one thing I want you to understand. But again, another thing that I want you to understand is that when this car is moving, again, any force that is directed, centripetal force will always be there. As long as an object is moving around the circle, centripetal force will always be there. Centripetal force will also be directed toward the center. Now, for the fact, where's Vachoka now?
My network is bad.
So what should we do?
No, we can continue.
Okay. So now for the fact that the centripetal force and the friction force are moving in the same direction. What did I say about when the forces are moving in the same direction?
They are equal.
Not they are equal. You equate them equal to each. Okay, yes. It's the same thing anyway.
Yes.
So I will say the friction force is equal to the centripetal force. So friction force is mu times the normal force. Centripetal force is mv squared divided by r. That's how it starts. It just starts like that. Normal force is mg. So mu times mg is equal to mv squared divided by r. There is m both sides, we can cancel m. So mu g is equal to v squared divided by r. In most cases, they are going to ask you to find the coefficient of friction which is existing. Okay? So if I cross multiply here, I can clearly say that the mu value will be equal to the v squared divided by rg. So I can use this formula to find the coefficient of friction. If I read question 2 from a throw sheet, a carton of eggs sits on the horizontal seat of a car as the car rounds a 26 meters radius bend at 15 or 16.5 meters per second. What minimum coefficient of friction must exist between the carton and the seat if the egg are not to slip? So this was moving around the circle. The coefficient of friction that the car is going to experience is going to be the same as the coefficient of friction that the carton of egg is going to experience. That's why the formula we're going to maintain. Vanve kaka?
Yes.
So we have already derived the formula. So the V is 16 point that squared. What is the radius? 26 times G 9.8. What is the coefficient of friction? What answer are you getting?
1.07.
But if you find the answer for mu as it is greater than 1, we always tell you that the mu is always less than 1. You have heard of that, that the mu should always be less than 1. You don't know about that?
So what does that mean for this answer that you know?
No, it is in the tutorial sheet. Then again, in that case, you should know that the normal force, the mu in normal is the friction force divided by the normal force. In all the cases, normal force should always be greater than the friction force. So in that case, if the mu is greater than 1, then it is the vice versa. So the mu is less, the normal force is less than friction force. But in rare cases, like in this case, if the question comes with the same scenario, can you answer? Hmm?
Yes, you can answer.
Let's go back to our drum. An object is
It
rotating.
says the previous one for the what the roundabout. You, I don't know if I got you correctly, but did you say that without the friction force towards the center, the car would move around the roundabout?
Yes, yes, yes.
Okay.
Yeah. So we an object is in the drum, but it is rotating. How is it rotating? It is rotating like that. This object cannot rotate if there is no friction force. It will just come direct. When we put it inside there, it will just come direct, then it just slip, then it comes in last punch up. But it will keep on rotating because, yeah, because of what? Because of friction. So now what happens is that is this. I've gotten this part here. Na kavi kapa. So there is a force of friction that is pointing upward. The FG is always pointing downward. So the gravity is trying to bring the object down, but because of friction is opposing it. Then it keep on moving around the circle in the drum. Now there is there is the normal force in that case, which is directed toward the center, because normal force by definition is the force that acts perpendicular to the surface. In this case, the surface is this one. The question that they're going to ask you here is to find the coefficient of friction that is going to, the minimum of coefficient of friction that is going to make this guy to keep on moving around the circle inside the drum. So how do we find? I want you to understand that this object is just moving in x direction. In y direction, the summation of all the forces, when I add them, should give me 0. So I've got the Fk pointing upward minus mg pointing downward in y direction. The net force is 0 since it is not moving in y direction. This is Fk minus mg. Shift mg to the other side, this becomes Fk is equal to mg. What is Fk, which is the friction? It is mu times the normal force is equal to mg. I'll end there. Now, I know that the question is demanding me to find the what? The coefficient of friction. But for the fact that they are going to give me the velocity, meaning that the velocity has to appear. You understand my point? So we'll say this, the forces that we have, the forces that we have in x direction, okay? The forces that we have in x, or what I'm going to say in simple terms, we are going to say the normal force is moving in the same direction with the centripetal force, because centripetal force will also be moving in the same direction. So we equate them equal to each other. So normal force in that case, we'll say it is m v squared divided by r. So this guy is what I'm going to replace where there is n. I don't know if I've made myself clear there. Hmm?
Yes, I
I can cancel m because I can clearly see that I've got m everywhere. If I cross multiply, mu times v squared will be equal to rg. I divide both sides by v squared, even here v squared. Therefore, mu is equal to rg divided by v squared. If we look at this now, I can plug in the values from here. But what I want you to understand is, remember these formulas, you will never run away from these formulas. I gave you these formulas. D is equal to theta times r. You will never run away. V is equal to W times r. A is equal to alpha times r. Like in this case, I want to find, I've been given from the question, let's read the question. A person is held stationary in a rotating drum against the wall by the static friction force exerted on him by the wall as shown in the diagram below. Find the required coefficient of static friction between the man and the surface of the drum to keep him from slipping downward. The radius of the drum is 2.5 meters and it is rotating at 0.6 revolution per second. But I've not been given the V. How can I find the V? Hmm? How can I find the V from our concept there? Guys,
You can multiply the angular velocity by the radius.
so if I will say mu will be equal to rg divided by, here I can replace with this, but it is squared. Simple. So r, if I want, I can say this is the same as that. I can cancel one r, this r, then here I remain with 1. G divided by this square times r. Let's plug in the values if at all what we are doing is right. So the mu value, the mu s will be equal to, G is 9.8 divided by, now we have to change this guy now. It's not supposed to be in revolution, it's supposed to be in what? Rad per second. So 0.6 revolution per second, we do it like this. Revolution then in over 1 second times. In one revolution, how many rad do we have? 2 pi. Revolution and revolution will cancel. So 2 pi times 0.6, that gives me 3.77. It's the same thing that we are getting.
Yes.
3.77, but we square it, then times the radius is 2.5. So what answer are we going to get? 9.8, I divide it, open brackets, 3.77 squared times 2.5. So I'm getting 0.2758. If I round it off, 0.28. Did you understand these things?
So for me, I think I'm understanding how you're connecting them. But my question would be, how were you able to identify it? Okay, in this question we use rad. In this question we use revolution per second.
Okay. So in any question, whenever we are talking about, we are dealing with the this radius r, then what should come in my mind is my answer should be in rad per second. That other question, the reason why this question, the reason why we thought of using the what? Did you see that the answer that we found here after using this formula for for theta to be equal to d divided by r. We said the answer here was in rad, not so? The one we found 67, it was in rad. Then we converted this now to revolution. You remember?
Yes.
So as long as I've used this conversion, then my answer is in rad. If if I've involved the radius, my answer is in rad. You get my point, huh? So even this one, the reason why we had to but it's fine for this question if at all you want to convert this one also to rad per second, for only that here they gave us the answers already. Then when you change this to rad per second, meaning that the answer that you found, that one as 67 rad, you are going to maintain it like that, and your answer is going to be also in rad per second. But I want to make things clear. When you are finding the velocity, okay, when you are finding the velocity, like in this case we are finding the acceleration, the initial speed you have been already given as in rad per second, meaning that even the answer that I'm going to find should be in, sorry, it is in revolution per second. Even the answer that I'm going to find should be what? Revolution per second squared. So it depends with the data that we have been given. So in this case, it is, if I can't use this guy as the way it is rad. The reason is because I've used that conversion of WR. So I can't say it is in E. So whenever I'm using this conversion of V is equal to this is always in rad. Timverana ka? Hmm?
I have another question.
But wait, have you gotten that one?
Yes, I've gotten this one.
Another question.
So for like we right now we are from deriving a formula where mu was equal to rg over v squared. This is the one where we were equating fk to mg. Then on like earlier on we equated fk to centripetal force, and then mu was equal to v squared over rg. It's like they swapped. Is
This,
that correct, or I didn't write the correct?
no, you're talking about this one, this question, eh? Question 2 and question 3, not question 2 and this one. We were talking about points we were solving mu, but the formulas are different. That's your question, not so?
Yes.
So this one which you can see on your screen there, this one, we use this one when you're talking about the roundabout. The car is moving around the circle. So when you're finding the coefficient of friction, we use this one. This is the scenario. So the scenarios are different. When we're talking about the drum, then now, that's when now we come to this. There will be another scenario where when we're talking about the banking curve, it is going to be another formula for coefficient of friction. So it depends with the scenario. What are we dealing with? Now when we're dealing with the drum, it is standard just like that. When we're dealing with the moving around the circle, it is also standard. When we're dealing with the banked curve, it is also standard. So they are not the same.
Okay, I understand now.
You have to understand. Yes, that's good that you have understood. Okay. So from what we have done today, we end